Hi, in this video we're going to look at the higher order functions map and filter, and then we'll also look at the function zip. These are all built-in functions and they're pretty useful. First of all, let's just recall the definition of a higher order function. A higher order function is simply a function that can take another function as a parameter, or it's also a function that can return a function. So if a function does either or both of those things, it's called a higher order function. So for example, we've seen this before, but the sorted built-in function is a higher order function because it takes in that key parameter, which is a function that allows us to change how elements in an iterable are sorted. We also have map and filter. These are both higher order functions as well that are built into Python. Now there are more modern alternatives to map and filter. We'll take a look at that in this lecture pretty briefly, and then we'll delve into list comprehensions and generator expressions in a later section in this course. But I want to show you in this video how those two things can actually also do what map and filter does. So let's look at the map function first. So the map function takes one parameter. The first parameter is a function, and the second parameter is this star iterables. So star iterables is a variable number of iterable objects, and func is simply some function. Now the only caveat, the only requirement is that func takes in as many arguments as you provide iterables. And this is because it allows us to basically take this function and apply it to the iterables, but in parallel. And I'll show you an example. It will become very clear what's going on there. So map will return an iterator. It doesn't return a list, it returns an iterator that calculates the function func applied to each element of the iterables, pairwise, or at least in parallel. And the iterator stops as soon as one of the iterables has been exhausted, which means that technically you can supply iterables that are not of the same length. It will basically stop at the shortest one. So let's look at an example. It will make it very clear what's going on. Let's take a look at this list L, which has three elements, 2, 3, and 4. And let's define this function sq that just returns the square of the argument x. So now we can call map, and we can pass in sq as one of the functions, at least as the function, and L as the one iterable in this case. So sq has to take in just a single argument because we're only passing a single list here, a single iterable. And that's the case, that's correct. So what it's going to do now, it's essentially going to create 4, 9, 16. It's going to look at each element in L and sequentially apply sq to each one of the elements, resulting in 4, 9, 16. Now remember, map actually returns an iterator, so I just call list around it in order to actually convert it to a list, so we can, and we'll see that in the code, but just so we can print it out and see what it looks like. So that's a very simple one. This is a function that takes in a single argument, and it is applied through map to a single iterable. Let's look at a different one. Let's take a look at two lists now, 1, 2, and 3, 10, 20, and 30. And suppose that we want to add up the elements pairwise. So we want 11, 22, and 33 as our result. So we can use the map function for that. Now how would we do this? Well, we're going to need an add function. So we're going to create an add function that takes in two arguments, and it will return the sum of the two arguments. So now if we map add to L1 and L2, well, map takes in two arguments, and we are passing two lists in here. So this works. And it's going to basically take an element from each list, L1 and L2, and then pass that to add. Then it will move on to the next item in L1 and L2 respectively, and pass that to add, and so on. And if we had uneven length lists over here, it would stop at the shortest length. So if L2, let's say, had 3 more elements, we would still only end up with 3 elements in our result because it would stop at 3, saying, well, I'm done. I've exhausted that list. I'm done. So if we do that, we get the answer 11, 22, and 33. Now, of course, we don't have to define add this way. We could just use a lambda expression to do the same thing. So you could do it this way. Map lambda x comma y, this is still a function that takes two arguments, returns the sum of the two, and then is applied to these two sequences, L1 and L2, and we get the same result. Now let's look at the filter function. Filter function basically takes a single function and a single iterable. So unlike the map, it doesn't take an arbitrary number of iterables. In this case, it takes a single iterable. What filter does, it allows us to specify a function that determines whether we retain or throw out the elements of that iterable. So it is essentially a filter. So iterable, it's a single iterable. Func is just a function that takes a single argument because it's going to be applied to the iterable, item by item. And then the function, if it returns true, this means that filter will retain the element of the iterable. If the function returns false or is falsy, it will throw it out. Again, filter returns an iterator. It doesn't return a list, it returns an iterator. So we'll throw a list around it, so that we can actually see what's contained in it. And it will contain all the elements of the iterable for which the function called on it is truthy. Now, if the function is none, you can specify none for your function. Then basically it just looks at the elements themselves, and if they're truthy, it will keep the element. If the element is falsy, it will toss it out. So that's one way of doing that, by using the none function. So let's look at an example. Let's say we have this list, 0, 1, 2, 3, 4. Now 0 is falsy, and all the other numbers in there are truthy. So if we were to apply none with the filter to L, it's going to evaluate the first element. It's falsy. It's going to toss it out. It's not going to retain it in our result. But 1, 2, 3, and 4 are all truthy, so it will retain those. And so when we look at the list of this iterator, then we actually get 1, 2, 3, and 4. Right? 0 was tossed out. We could also do it this way. We could do this. We could define this function is even, which basically just tests to see if n mod 2, is equal to 0. Right? If n is divisible by 2, means the remainder is 0, that's an even number. So now we could filter this list out with is even. So if we do this, well, 0 mod 2 is going to be 0, so it's going to be kept because 0 is even. 1 mod 2, however, is 1, so it's not equal to 0, so this function would evaluate to false, and so 1 would be tossed out. 2, on the other hand, 2 mod 2 is 0, so this expression will be true, therefore 2 will be kept, and so on. And so we end up with 0, 2, 4. Now, of course, once more, we don't have to define the function outside. We can just do it inline using a lambda expression. It works exactly the same way, and we get 0, 2, and 4 back as well. All right, so now let's move on to the zip function. Now, the zip function isn't a higher order function, but it's really, really useful in conjunction with higher order functions and with list comprehensions and generator expressions. So let's take a look at the zip function. It is a function that takes in an arbitrary number of iterables. So it operates on iterables. There is no function being passed in here. Zip is not a higher order function. It's just a function that takes multiple iterables and will return one iterable. And what does it do? Well, it basically combines each element in the iterables kind of pairwise, right? One at a time. So in this case, if we zip this up, we will actually get a list, or actually an iterator, that will be the tuples formed by each element of the two iterables one by one. So 1, 10, 2, 20, 3, 30. It's called zip, right? You can think of it as taking two lists and zipping them up like a zipper, right? You're kind of putting it together. What you end up with are tuples. And again, it will stop at the shortest one. Then we'll see examples of that. So let's take a look at another example. Let's say we have 3 lists. Remember that zip can take an arbitrary number of iterables. So let's say we have 3 lists. Well, if we zip that up, right, if we zip those 3 lists up, we're just going to get another iterable that will contain tuples with 3 elements in each. right? It's going to contain 1, 10, and A, 2, 20, and B, 3, 30, and C. Just one by one. If we have an uneven length, so let's say that our first iterable has 1, 2, 3, 4, 5 elements, and our second iterable has 1, 2, 3 elements. Now we can still zip that up. That's still going to work. The only thing is it's going to stop at the shortest one. So once one of the iterables is exhausted, it doesn't matter what's left over in the remaining iterables, it won't show up in here. So here we get 1, 10, 2, 20, and 3, 30 in our result. So let's take a look at another example. Now, L3 is the string, but remember a string is an iterable. You can iterate the characters in the string. So you can think of this string as simply the sequence of characters P, Y, T, H, O, N. So it has 1, 2, 3, 4, 5, 6 characters in it. L2 has 4 integers in it, and L1 has 3 integers in it. Now we can zip that up. And if we zip that up, and of course we pass it to a list so we can actually see the result, then we will get 1, 10, P, 2, 20, Y, 3, 30, T. Now L1's been exhausted, and so we stop at that point. And so this is what we end up in our result. All right, so it's actually pretty handy. Let's see why. Let's say that I want to find the index of each character in the string, and I want to create some kind of list or something that tells me both the index and the character at that index. Well, it's very easy to do that. I'll take this range and I'll make the range number here greater than the length of this string. I could make it equal, but I can make it greater than. Anything, it doesn't matter. Because now when I zip that up, it's going to zip up 0, 1, 2, 3 up to 100 and ABCD, and I know it's going to stop once ABCD has been exhausted. And so our zip result is 0A, 1B, 2C, 3D. So as you can see, that's really handy. Now, of course, if you want the tuple the other way around, if you want A, 0, B, 1, you just zip L2, L1, right? The sequence, the order of the sequences matters in terms of how it shows up, in what order it shows up in the resulting tuples. Okay, so now let's look at list comprehensions. And again, we'll see that in much more detail later on in this course, but let's take a look at this and why it's an alternative to the map function. Let's go back to this example, L equals 2, 3, 4. And let's say that we want to return the square of each element. So we want to create a list that contains the square of each of those elements. So we can do it using a map, right? We can define this function SQ. We could, of course, use a lambda expression as well. And then we map SQ to the list L. And so when we get that, and of course, we can use the lambda expression. Here's the example here. And when we get that back, we get 4, 9, and 16. So that's using the map function to generate a new list. So we had to use list, then map, then specify the function either using a lambda or using this definition out here, and then the iterable itself, whose elements we want to square. We could also have done that using a for loop, right? We could start with a result, which would be an empty list. Then we can loop through every element in L, so for x in L, and then we would append x squared to this result. And then if we were to print the result out, we would get the list 4, 9, 16. Right? So that's another way of doing it. This isn't using map. This is just using regular code and a regular for loop. The list comprehension is very similar to the for loop example. You basically have the expression here, x squared. This is what we want to return for every x in L. So here's our loop for x in L, right? You have it right here. The only difference is that I don't have to do a result.append. I already have the square brackets here indicating the list. So it's going to iterate L. It's going to put each element inside this variable called x, and then I can use x in this expression here and do whatever I want with it, like in this case, squaring it. So when we do that, we end up with 4, 9, 16. So this is actually a little easier to understand than this statement over here. That's still okay. That's still pretty straightforward. Map SQ to L. I know that SQ does x squared, or I can see it directly here if it's a lambda expression. That's still okay. So in general, you can write expression for var name in iterable and just square brackets that will create a list. And so that's called a list comprehension. Let's take a look at another example. Let's suppose that we have two lists. L1 is 1, 2, 3 and L2 is 10, 20, 30. Now in this case, here's my first attempt. So I take map, I take lambda x comma y, x plus y, and I apply that lambda function to L1 and L2. So obviously I'm adding up the elements of each of those lists, those sequences, and then I'm generating a list back out of that. And so we get 11, 22, 33. That's the example we saw just now. Okay, now I want to remind you of the zip function. So what happens if we zip L1 and L2? Well, we end up with tuples, right, that are made up from the corresponding elements of each list. Right, so 110, 220, 330. So zip is something that becomes really, really useful when we use list comprehensions. Because suppose I want to write what I just did here using a list comprehension instead of using this map. Well, we can do it this way. We can iterate zip L1, L2. Now, what are we iterating? Well, we're iterating a tuple, right? And so we can put each element of the tuple into a variable name. We've seen how to iterate before. So for x, y is zip L1, L2. We'll get 1 and 10 in the first iteration, 2, 20 in the second iteration, and 3 and 30 in the third. And at each iteration, what are we doing? We're summing up x plus y. And then we're putting that into a list. And so we end up with the very same thing, 11, 22, and 33. So now you may be thinking, well, wait a minute. I mean, yeah, what's simpler to understand, the list comprehension or the map? In this case, I think it's a toss-up, right? The map is pretty straightforward to understand. Here you've got the zip that kind of came in between that, otherwise would have been, much cleaner. But up to you to decide which approach you want to take. But here's another one. Let's take a look at the filter function. So let's take a look at L equals 1, 2, 3, 4. And we want to filter out only keep the even numbers. Well, we've seen this before, right? We can filter, we can take this lambda expression that looks at whether n is even or not, and then we apply it to L. We only retain the truthy results. So in this case, we retain 2 and 4. Now, if you were to use a list comprehension, you can do it this way. The list comprehension has an extra piece that you can add on to it, which is this if statement. And the way it works is that we are iterating x in L, and we're going to return x, so we're just going to take x by itself. We're not doing anything fancy with it, but we're only going to keep those x's, those iterations, where this expression is true. In other words, return x for x in L if x mod 2 equals 0. So that's pretty expressive. Again, this is, I think, easier to understand than this filter operation here. Again, up to you how you want to do it. So this will give us the same thing, 2 and 4. And of course, we're using a list comprehension, so we actually get a list back. We don't have to convert it to a list. It already is a list. So in general, list comprehensions are built this way. You first think of the iteration. So you're going to iterate something in some iterable. Now that something could be a single variable name, but if you're iterating, a tuple, for example, you can have multiple variable names. Kind of depends what you're iterating. Then you have a filter expression that only keeps this iteration if this expression over here is true. And when that's the case, then it will evaluate this expression here, and that will become the element of the new list. And we just repeat that for every iteration. So let's combine the two. And this is where you'll see that using a list comprehension is actually a lot more expressive and a lot easier to understand than using map and filter. Let's say that I have this list here. Well, it's not actually a list, but it's a sequence, right? Range 10. It's an iterator. And I want to do this piece of code right there. So what's going on? Well, let's take a look. We have filter, right, which is some function applied to a list, well, to a sequence, to an iterator. What is that iterator? Well, it is itself generated from map that applies the function x squared to the elements of L. So what we're doing is we're squaring every element that's in range 10, and then we're filtering out the elements where that square is less than 25. We're only going to keep the elements where the square is less than 25. So what we end up with is 0, which is 0 squared, 1 squared, 2 squared, 3 squared, 4 squared, and then 5 squared is 25. That's too large. That gets filtered out. And so do the remaining elements of range 10. So you certainly can figure out what's going on here, but it takes a little bit of work. On the other hand, if you use a list comprehension, here's what it looks like. X squared for x in range 10 if x squared is less than 25. That is very, very clear. You don't have to really think at all in order to understand what this list comprehension is doing. And it is, of course, returning the same thing. All right, so we'll take a look at list comprehensions and generated expressions and dictionary comprehensions in more detail later on in this course. But for now, I wanted to start showing you how those things work and why they're really an alternative to the map and the filter higher order functions that you'll still see used quite widely by Python programmers. So let's switch to some code and let's see all that in action.